guys, so this is a video, the last one, yay, of this topic. Okay, so how do we do these sort of things? It says we have to sketch a graph of the following relations and state their domain and range. So this is just, as you can see, it only has points. Is that a problem? No, because a relation is any set of points of the Cartesian plane. So if we draw this relation, and it's going to be a little bit, it's not the best drawing, but so -2, -1. There's a point, going to be a point there. There's going to be a point at -1 there. There's going to be a point at -1, 1 there, one at 0, 1, and one at 1, -1, which is down here. So what's the domain? Well, in this case, the domain is, well, as you all know, the domain is the x values where the function exists. So what function x values does the function exist at? It exists at -1, it exists at -2, it exists at 0, and it exists at 1. So that's the domain. Now the range is the set of y values. So the range is going to be just -1 and 1 because they're the only two y values where this graph actually exists. So that's that one. Now this one might look a little bit like a circle, but it's got this square root sign. When it's got this, what I want you to do is go on your calculator and actually draw it on your calculator. Put this into your calculator and draw it. So if you do that, what you get is a circle, a semicircle with center of 5 and radius of 2. So it's going to be a semicircle like that. That's -2 and that is 2. Alright? Now you might say, how on earth do you know that? Now that center is not actually included in here, so all that's included is this bit. Alright? Well, if you draw it, that's what it will look like. But how else do you know that? Well, if you square both sides of this equation, you get y squared equals 4 take x take 5 all squared. You don't need to know this. All you need to know is to be able to do the domain and range of it. Then if we added x take 5 all squared to both sides, we'd get rid of it from that side. And so we get that. So this is the equation of a circle with center 0, 5. Center 5, 0, sorry. Center 5, 0 and radius of equal to 2. So that's a circle, but because it's a square root, that means that this bit inside here has to be greater than or equal to 0. And that turns out that it actually forms a semicircle when you do that. Alright, so you don't need to know all that. All you need to know is if you get something like this or something that you don't know what it looks like, put it in your calculator, draw a picture and state the domain and range. So if we're doing the domain and range of this lad, it would end up being, the domain would be x, like that. So x is what? Well, x is less, the graph exists when x is greater than or equal to -2 and less than or equal to 2. Alright? The range, y is such that y exists. When does y exist? Well, when y is greater than or equal to, here this is 5. So if you're going to sketch this, you'd have to draw a scale. So you'd put 5 there, or you'd put, 2, and so that we knew what the scale was, -2. So y is going to be greater than or equal to 5 and less than or equal to 7. If you're doing your calculator, I didn't draw it the best there, but it's actually less than or equal to 7, and that makes sense because the radius is 2. So this is actually 2. That's because 4 is r squared, so r equals 2. Alright, hope that makes sense. So let's keep going. Function notation. What is a function? So we might talk a lot about f of x and stuff. F of x is just the same as y. Alright? It's just something you do to x to produce something else. So, for example, think of it like a machine. You put x into your machine, into f of x, into your machine f, and it produces f of x. So this example is you input x equals 3 into your function f x squared and you get f of x equals 9. Well, what on earth is that saying? Well, say your function f of x equals x squared. Alright? So that means that my machine is squaring x. So if I want to find f of 3, what that means is I put 3 into that machine And so 3 goes where x goes, and I get 3 squared, which equals 9. Alright? So what about this one? Max was informed that to improve his chances of being picked in the preseason draft, he would have to gain a significant amount of muscle mass. He went on a strenuous training regime. His mass after T months of training was given by this equation. M of T equals 3T. I'm going to write that again. Equals 3T plus 56. Find M of 3 and interpret your answer. Alright. Whenever you get this question, it means that the number inside the bracket replaces this variable. Alright? So wherever T appears here, 3 will go instead. So M of 3, we're just going to replace every T by 3. And you're going to get 3 times 3 plus 56, which is going to be 65. Alright? So after 3 months of training, what is this saying? Well, M is the muscle mass. So his mass is given by the equation M of T. So M is the muscle mass. So after 3 months of training, Max weighed 65 kilos. Cool. Let's keep going. Find T when M of T equals 67 and explain what it represents. So we're saying M of T equals 67. That means that 3T plus 56 actually is equal to 67. So 3T must equal 67 take 56. Oh, that's a horrible 56. Take 56, so that equals 11. So T must equal 11 on 3. So, which is 3 and 2/3. So T months. Alright, T is the time in months. So this is explaining what it represents. Make sure you do the whole question if you get these questions. Don't just find it. Explain what it represents. So this means after 3 and 2 months, 3 and 2/3 months, Max weighed 67 kilos. Alright, that's what that means. And the final bit is, before the training regime, what was Max's initial mass? If they ever ask you about initial, it's meaning when T equals 0. So all we have to do is find M of 0. So that's going to be 3 times 0 plus 56. So 3 times 0 is 0, so it's going to equal 56. Right? That's right, isn't it? That it was 56. Pretty sure it was. So his before training, his mass was 56 kilograms. That's all that is saying. Alright.